When will NASA colonize Moon? Humans haven't set foot on the Moon in more than half a century, but NASA's Artemis program is going to send them back with a series of missions soon. When the first astronaut plants her boots in the lunar soil in 2025 as part of Artemis III, assuming the current schedule holds, it will be the start of an even more ambitious project than sending humans back to the Moon, as NASA plans to construct a base camp somewhere among the gray dust and craggy rocks of the Moon's south pole. This lunar outpost will allow the Artemis missions to eventually shatter Apollo 17's record for longest stay on the Moon, while serving as a jumping-off point for in-depth exploration. So, how is NASA planning to build a moon base? Let's find out. Welcome to Space World. In today's video, we are going to talk about when will NASA colonize Moon. So, if you want to know more about it, then stay with us until the end of the video. NASA's Artemis program will mark a significant milestone in U.S. spaceflight history when it lifts off in late 2024. Not only will it be the first time that American astronauts have traveled further than LEO since the 1970s, and not only will it be the first opportunity for a female astronaut to step foot on the Moon, the Artemis mission will perform the crucial groundwork needed for humanity to further explore and potentially colonize our nearest celestial neighbor, as well as eventually serve as a jumping-off point in our quest to reach Mars. Given how inhospitable space is to human physiology and psychology, however, NASA and its partners will face a significant challenge in keeping their lunar colonists alive and well. Back in the Apollo mission era, the notion of constructing even a semi-permanent presence on the surface of the Moon was laughable, largely because the numerous lunar regolith samples collected and returned to Earth during that period were found to be dry as a bone. Rob Mueller, senior technologist in advanced projects development at NASA, said during a South by Southwest 2021 panel, that was the common wisdom. There is no water on the Moon, and so for many years, that was the assumption held in the aerospace community. And it wasn't until the late 90s that a neutron spectrometer aboard NASA's Lunar Prospector mission found telltale evidence of hydrogen atoms located at the Moon's poles, suggesting the potential presence of water ice. And it wasn't until last October that the SOFIA mission detected water on the sunlit surface of the Moon, rather than only squirreled away in deep, dark lunar craters. We had indications that H2O, the familiar water we know, might be present on the sunlit side of the Moon. Paul Hertz, director of the Astrophysics Division in the Science Mission Directorate at NASA headquarters, said at the time. Now we know it is there. This discovery challenges our understanding of the lunar surface and raises intriguing questions about resources relevant for deep space exploration. Based on this new evidence, Mueller estimates that there should be enough water ice available to launch a vehicle like the Space Shuttle every day for 2,000 years. So there's a lot of water on the Moon. The trick is, we have to find it, access it, and mine it, and then economically use it. In addition, the revelation that the Moon holds a cache of water, which can be used to both quench an astronaut's thirst and power their rocket, could set off a resource grab the likes of which we haven't seen since the days of the 49er. Pete Corrado, senior consulting engineer at the Bechtel Corporation, noted during the same panel discussion. So the next gold rush to me is to the south pole of the Moon, and it's a harsh environment. This is because the larger accumulations of water are located in permanently shadowed regions, where the sun's warming rays cannot reach the ice and vaporize it off the Moon's surface. Problem is, the temperature in these regions hovers around a brisk 40 degrees Kelvin, which is colder than liquid nitrogen. That's so cold that even modern mining rigs built for the Earth's most extreme environments would have a hard time operating there. You get metal parts down that cold, they become almost like glass, Corrado declared. It's also a hard vacuum on the Moon, so you're going to have some really strange problems like cold welding of metals, Mueller added. If two metal surfaces are exposed to each other, they can actually bond in a hard vacuum. And we've seen that before in space. It's a well-known problem. Adding to these, the ubiquitous razor-sharp, potentially DNA-damaging electrostatic dust found on the Moon poses a danger to colonists, one that NASA has been grappling with since Apollo 17 astronaut Harrison Schmitt came down with the first case of lunar hay fever. This dust not only clings to rovers and spacesuits, but the minuscule particles also worm their way into sensitive electronics, clog filters, jam zippers, and freeze joints. NASA has developed a dissatisfying coating to counter the dust's electrical attraction, but its effectiveness at scale remains to be seen. The micrometeorites themselves, whose impacts with the surface create this dangerous dust, will also have to be taken into account when designing lunar habitats. But unlike the Apollo era, which helped usher in the Cold War, this time the American government is not going it alone. The Artemis program is deeply coordinating its efforts alongside a host of international and commercial partners, such as SpaceX, which is tasked with delivering pieces of the Lunar Gateway into orbit around the Moon in 2024. This will let us do for a reasonable cost with arguably a return on investment, but we can't do it with NASA. NASA is a government agency. The role of the government is to facilitate industry, Mueller explained. And so we're setting up the framework, the infrastructure, and all the processes, the legal framework, communications, launch sites. This is all necessary. And then private industry can come in and do what they know how to do, which is make some money and create an economically efficient system. Moreover, while partnering with other nations in this endeavor is a great way to spread the upfront costs around, it could lead to conflicts as to which member nation will get access and rights to which resources. Currently, such matters are governed by the UN's Outer Space Treaty of 1967. However, its language is not entirely clear, leaving the rules open to different readings. The U.S. interpretation is that we will not claim the land or claim sovereignty, but we do have the right to use resources, and the commercial industry has the right to use the resources, Mueller says. What's more, the Outer Space Treaty lacks specific enforcement mechanisms and has yet to be ratified by any signatory nations, making its rules more like suggestions. The Artemis Accords similarly are guidelines rather than directives, though if enough nations sign onto it and act within its framework, he continued, over time it becomes de facto law. Mars poses many of the same challenges in exploration and eventual colonization that the Moon does, such as deadly radiation, micrometeorite impacts, and clinging dust particles, not to mention the 6-month trip needed just to get to the former compared to a measly 3 days for the latter. That vast distance also strains our ability to remotely control rovers and other teleoperated robotic systems we send to the Red Planet due to the minutes-long communication lag. In addition, prospective explorers and colonists will have to contend with the wide temperature ranges that exist at each destination. On the Moon, for example, the sunward side can be as hot as 125 Celsius, while the shadowed side can drop to minus 175 Celsius, causing intense thermal stress on objects moving between them. Protection from galactic and solar radiation will also have to factor heavily into any decisions regarding where to settle on the surface. Shaded valleys and cliffside locations offer a higher degree of natural protection, so we'll have to carefully consider the local topography when picking settlement sites. One potential solution to the radiation problem would be to ensconce our artificial habitats with a 3D printed shell made from the Martian soil itself. Xavier de Castellier, head of design technology and innovation at Hassel, noted during the panel. Therefore, maintaining the crew's physical and mental health on these increasingly long-duration missions will be of paramount importance and will have to be accomplished without help from home. Should we manage to surmount these challenges, however, the rewards will be substantial. It's very difficult to live in space, Mueller said in a separate panel discussion at South by Southwest 2021. The good news is that there are a lot of resources in our solar system, and beyond, there's almost an infinite amount of resources compared to what we have on Earth. These include everything from water, atmospheric gases, volatiles, and rare metals to the crew's own trash waste to energy. So, if you have sunlight, then you have access to energy, and humanity has already shown that it's capable of inhabiting some of the most inhospitable areas on the Earth, such as Concordia Station in Antarctica. With continued diligence, research, and international cooperation, the stars themselves could soon come within our reach. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.